In the previous video, you were introduced to the idea of zeros and how we can create those types of solutions based off of just knowing what the zeros are. We talked about multiplicity when there's a kickback based off of the exponent. Here we're going to be talking about what the relative maximum and relative minimums are all about. So as you can see, some of these zeros will have the line run straight through it. Sometimes it kicks back. Sometimes it just cuts right through it. As we saw in the previous example, we dealt with some examples that looked like this, where it was going up, going down, but then bounced back based off of the zero. So what this introduces is the idea that there can be a relative maximum or minimum. Ideally, maximum is the value of the function where there's an up to down turning point. So this bit right here, this point, would be our relative maximum. Relative minimum is the lowest point from the left to the right from a down to up turning point. So we'll see how these look based off of graphing these out on a calculator. So for this, you will need a graphing calculator. I think that's the easiest, or well, that's one way to do it. You could also do it on Desmos, but for this, I'm going to use a graphing calculator. So I'm being given this function to graph, x cubed minus 9x. So let's first graph that. So we have x cubed minus 9x. Let's get rid of this so that doesn't come up, or that. And so if we graph this out, we see that there's a bit going on. Let's zoom in so we can get a feel for what exactly is going on. Try and zoom in towards the middle. All right, we're getting a little bit closer now. So how can we go about getting this maximum and minimum? Well, we've done a lot to graph this. This is going to be similar to how we found solutions before, so let's do that. So let's hit second, trace. Let's go first for maximum. Pretty confident that there's a maximum up at the top of this hill, although it's not in sight. So let's set our bounds to the left and to the right of it. We see that we now are there. So let's try to zoom in a little bit closer. So we can see that we have this top of the hill. This is definitely going to be a maximum. So the question's asking us to give an approximation. So the maximum here is negative 1.732. So relative maximum is negative 1.7. And it says round to the nearest tenth, so that's what I'm doing here. So negative 1.7, that's our maximum. As far as the minimum goes, let's go back to the graph. We know that down here, let's zoom in on it, we see that this is kicking down and then going back up. So we see the minimums approximately here. We can get a little bit more precise if we hit second, trace. Now we're going with minimum. We can set a left bound, set a right bound, hit enter again. We see that we also have the positive version of this, so 1.73. So let's write this down. Is when x equals 1.7. Let's round that up. So that's that graphing for relative and maximum minimums. I'll give you a moment to try the next one. So you're graphing this out. For this, I'll switch to Desmos actually. So we're being asked to graph 3x cubed. We are then adding x squared, we're subtracting 5x. So when this is graphed out, let's see it. We see graph looks like this. We can get zeros here, here, and here, which is nice, but we're aiming for the maximum. So we see here, when x is negative 0.86, that's where we have this maximum relatively. So let's write that in. We had that as maximum, which would be the coordinate, negative 0.8. I guess you could round it to 0.9, but I'll do it to the nearest tenth. So this would be approximately an x coordinate of negative 0.9. where the y coordinate is 3.1. So this is where our maximum is. For the relative minimum, we can see that on the down part, down here, where the x coordinate is 0.6. So let's write that in. So we have 0.6, comma, and then that y outputs approximately -2. So we've got that. And this is all based off the calculator. It's either top of the hill or bottom of the hill. As you can see from the visual, these can be pretty easy to find, or spot at least.